Hello everyone, I am Charan. My registration number is 21BEC7159. I am going to discuss question number 1.20 from the book Signals and Systems by Oppenheim. So this is the question 1.20. A continuous time linear system S yields the following input-output pairs. Input is x1 x of t and output is y of t. For the input e power j2t, the output will be e power j3t. And for the input e power minus j2t, for the system S, the output will be e power minus j3t. So what we have to find? We have to find two. First one is for the we have to find the output y1 of t. For the input x1 of t is cos 2t. And second one, we have to find the output y2 of t. For the input x2 of 2 is cos of 2 into t minus 1 by 2. So here is the solution. Here given the system is linear, it is a linear system. The system is linear, it should follow two conditions. First one is for the system the input is x1 of t and the output is y1 of t. If we multiply with a, if we multiply the input with a, we get a into x1 of t, the output should be a into y1 of t. This is one of the condition. The second condition is for a system with input x2 of t and output y2 of t. So if we add these two inputs, we will get the input x1 of t plus x2 of t for the system S. The output should be y1 of t plus y2 of t. For the inputs x1 of t plus x2 of t for the system S, the output should be y1 of t plus y2 of t. This is additive property. So the given system satisfies these two conditions. So first, the input x1 of t is cos 2t. Input x1 of t is cos 2t. Cos 2t is e power j2t plus e power minus j2t whole divided by 2. So it is given that for the input e power j2t, the output is e power minus j2t. E power j3t. If you multiply with 1 by 2, if you multiply the input with 1 by 2, you get the input 1 by 2 e power j2t. The output is 1 by 2 e power j3t since the system is linear. Similarly, for input e power j2t for the system S, the output is e power minus j3t. Similarly, if I multiply this with 1 by 2 e power j2t, the input 1 by 2 e power j2t. For the system S, the output will be 1 by 2 e power minus j3t. If we add these two, the input will be 1 by 2 e power j2t plus 1 by 2 e power minus j2t. So this is the input. The output should be also the sum, that is 1 by 2 e power j3t plus 1 by 2 e power minus j3t. So this is nothing but we can write this as e power j2t plus e power minus j2t whole divided by 2. This is also we can write as e power j3t plus e power minus j3t whole divided by 2. So this is nothing but cos 2t. So this is equal to cos 3t. So for the input x1 of t, it is equal to cos 2t. For the system S, we get the output y1 of t. Y1 of t is equal to cos 3t. Next, x2 of t is equal to cos of 2 into t minus 1 by 2. So we can write it as cos of 2t minus 1. In general, cos theta is equal to e power I j theta plus e power minus j theta whole divided by 2. As same as the previous one we did. So cos of 2t minus 1 can be written as e power j into 2t minus 1 plus e power minus j into 2t minus 1 whole divided by 2, which is equal to e power j 2t into e power minus j plus e power minus j 2t into e power j whole divided by 2 is equal to 1 by 2 e power minus j power j 2t plus 1 by 2 e power j e power minus j 2t. So as given, for the input e power j 2t, for the system as the output is e power j 3t. This is given. If we multiply this with 1 by 2 into e power minus j, we get 1 by 2 into e power minus j into e power j 2t. This will be input. For this input for the system s, we will get the output 1 by 2 e power minus j e power j 3t. And we are also given that for the input e power j 2t, for the system s, we will get the output e power minus j 3t. So if we multiply with this 1 by 2 into e power j, 1 by 2 e power j e power minus j 2t, this for this input for the system s, we will get the output 1 by 2 e power j e power minus j 3t. So if we add this, since the system is linear, if we add this, if we add the inputs 1 by 2 e power minus j e power j 2t plus 1 by 2 e power j e power minus j 2t. As the system s, we will get the output which is the sum. So we will get the output as 1 by 2 e power minus j e power j 3t plus 1 by 2 e power j e power minus j 3t. So this is equal to cos of 2t minus 1. We have written as cos of 2t minus 1 is equal to 1 by 2 e power minus j e power j 2t plus 1 by 2 e power j into e power minus j 2t. So we can write it as cos of 2t minus 1. So we can write it as this equation, we can write it as e power j into 3t minus 1 plus e power minus j into 3t minus 1 whole divided by 2, which is equal to cos of 3t minus 1. You can simplify this and write it as e power j into 3t minus 1 plus e power minus j into 3t minus 1 whole divided by 2. So for the input x1 of t, x2 of t is equal to cos of 2t minus 1 or cos of 2 into t minus 1 by 2. We will get the output y2 of t is equal to cos of 3t minus 1 or cos of 3 into t minus 1 by 3. So this is the solution for the question 1.20. Thank you.